Thank you, David, for the introduction. So I think that now our society, big data is a huge challenge. There are enormous amount of data coming from sensors and all the experiments. The critical issue is how to utilize this data. So my work is in collaboration with Intel, and is funded by Intel as a parallel computing center at Indiana University. So there are a lot of colleagues I work with, including Tom Sterling, Marty Sweeney, and Jeffrey Fox. So it's a great privilege to work with these very distinguished colleagues. To the broader extent, I have a collaboration. It's funded by NSF big data project. We have a talk in detail. This is incorporating in the institution at Rutgers, Virginia Tech, Kansas, Stony Brook, Arizona State, and Utah. So the mission of the Intel Parallel Computing Center at Indiana University is really to foster the modernization of applications. Because of the parallelism and scalability through these hardware coprocessors and microprocessors can provide tremendous computing capabilities that cannot be done without. Initially, there are two projects funded. First one is simulation, led by Professor Steve Gottlieb from Physics Department. Another one is led by me, is data analysis. So as we know that simulation and data analysis are two pillars, fundamental computing capabilities for advancing science discovery and commercial services. So here our research is really on the fundamental science and engineering, how to advance all this using computer hardware and technologies. Steve's work is really do simulation using Milk code. It's really study the fundamental physics theory. My work is try to build high-performance iterative computation, which has MPI quality to support broad range of machine learning and data analysis libraries. So one of the critical issues that are facing all of the people building scientific application is really illustrated in this chart. Many people build applications in different domains, and normally what they do is that they choose an algorithm and use specific language and tools to implement that. However, the problem of this approach is sustainability. So when you have changes from hardware level to library to tools to different languages or favorable languages, and then you may considering to reinvent or re-implement all the kind of software systems. Another problem is scalability. Normally, those kind of software and libraries built around a small group of researchers or companies, but all of this involvement in this modern computing landscape changes very fast. To address that problem, we're trying to study fundamentally how to build software building blocks, which can be the kernels and the libraries, so can be used by all these kind of teams and researchers or companies. So we're trying to illustrate that concept using integration of Hadoop ecosystem. You know, that's a big data framework, and invoke Intel's intranode libraries. So build that as the kernel building blocks as a library. And we want to move forward in the future to make it open source to be widely accessible by the community using Apache software. And this is really our vision, how to foster big data convergence between HPC and the big data using the technologies we have. So the last one I want to mention is that we are funded by NSF a year and 8 months ago. This is the DataNet project. It's a big data project. It's $5 million project in collaboration with 6 institutions. And we're trying to build a middleware and high-performance data analysis library to support different domains, including, if you look at the chart, is network science, biomolecular simulation, polar science, and pathology, image processing in health. So this is an exemplary example how we can build a high-performance library to support different kind of science discoveries. To end up my introduction, I really want to invite people to give us feedbacks, what kind of tools, you want to get support, and we want to invite people to collaborate with us. And we hope that we can build tools to make your dream of applications easier to develop. Thank you so much.